Okay, so exploiting local dev environments, or in other words, Mallory's coming for you. So we'll get acquainted with Mallory in just a second. But before we do that, we're just going to kind of go into the talk scope. And basically, we're going to be focusing on the faulty security assumptions that we make, okay? And that includes DevOps engineers and developers. I have pivoted through both roles in my career, and you know what? Hey, we all are human, and some of these assumptions, I have made myself, right? And so we all are learning together, is basically what I'm getting at. And also, you will be seeing a technical exploit that you can run locally. So, yeah, there's definitely some practicality to what you're going to be seeing in the next few modules. And also, the key takeaway here is not necessarily patching the exploit. Hey, we'll go into that. But really, I think that if you do an 80/20 analysis, to me that 20 is it's about patching our assumptions. In other words, we are transitioning from unknown unknowns really to known unknowns. And yeah, so we'll get into all that in just a second. So for the first half, let's basically just going to be outlining kind of from a technical perspective what we're going to be going over. So this is really more of a refresher, the first half. So we're going to be going back over the same origin policy, cross-source resource sharing or CORS, and also cross-site scripting or another and we're actually going to be looking at a particular type of it called DOM XSS or DOM cross-site scripting. So if you kind of are familiar with these topics, I suggest maybe going through this video on 2x and because I'm going to be kind of basically introducing some scenarios that we're going to see in the full exploit through kind of this refresh some of these refresher basically topics. So if yeah, so I think a 2x kind of speed should do you pretty well. But if you don't want to even do with that, you can just skip ahead to the next module, which will be the second half. Okay, so let's. Oh, and also I'm just going to kind of introduce you to the second half, just so you can kind of get an understanding of what's coming up. So basically, there's going to be an exercise, and the goal of the exercise is to exploit a local dev environment to steal production data. And in this scenario, there's going to be a developer who is running a local Elasticsearch Community Edition 5.6.9 database. And the cores is going to be disabled to help, quote unquote, the development workflow. All right. And also, this developer is going to be signed into a corporate VPN. Also, in this scenario, there's going to be a production Elasticsearch database, and why it's Community Edition and basically the version that I'm. Why is it that it's the Community Edition? Well, sorry, I will get to that. But it's just kind of hinting a little bit on items to come. But anyhow, all right. So that production Elasticsearch instance is going to be on a corporate VPN, and CORS is going to be enabled. And also, there's going to be an interplay here with Beef, which is the browser exploitation framework. All right, so let's really start on that first half, the refreshers. So the same origin policy, or the SOP. So this is a browser security mechanism. And the origin within the same origin policy, really, it's basically where did the request originate from? From the vantage point of the browser, okay? So, all right, so if your browser, say, visiting evil.example.com's homepage for outgoing requests, evil.example.com is the origin. So, just really in a nutshell, I'm not going to go into every excruciating detail, but it's still good. The details are still good to know. But anyhow, of the same origin policy, just for brevity here. But just in a nutshell, the same origin policy restricts how origins can interact. And so for example, say that evil website's JavaScript is limited in how it can interact with, say, your bank's API. And this is absolutely crucial, right? If you have authentication cookies that are scoped to your bank's API, because they will be naturally kind of go with the request when the browser sends it off. Okay, so Now, here's the question. You can just kind of think to yourself and pause the video for a second. How can the same origin policy be relaxed? Okay, and that is through cross-origin resource sharing, or in other words, CORS. So let's do a brief refresher. So CORS is an HTTP response header that is sent to the browser. And you're like, what happens if a server sends this CORS header back to the browser right here? Okay, well, okay, so say that evil site that we saw, that evil site's JavaScript now has more access to a given server or whatever server sent down that header. Okay, so all right, so in certain situations, that means that the evil website can now submit any type of REST request to the server. And all right, so I know I've seen this, right? Have you ever seen this access control allow origin wildcard before? I know I have. And it's really I have seen this in non-production systems, okay? I've also seen it in prod. I think we all have, unfortunately. But in I've seen it really it's been prevalent in my experience in more developer environments. And why is this? Because this allows for really a high variation of origins. For example, a dev or somebody else can have localhost as their origin, 127.0.0.1, or they can say change their Etsy host and do some other magic, right? So this is basically kind of, yeah, I've seen this almost as the standard, unfortunately, in dev environments. And then now we're just kind of starting to branch out a little bit, start to think how cross-site scripting could potentially take advantage of this wildcard CORS access. And we'll actually be exploring cross-site scripting within OWASP, their Juice shop. It's an intentionally vulnerable web application. I'm just going to call it Famazon Juice shop, but anyhow, but probably just call it the shop just to make it easier. But anyhow, in this scenario, with Juice Shop or the shop, there's going to be Evil Mallory, okay, and there's going to be Victim Bob. These are going to be our characters. And so now, all right, I had to kind of get that out of the way to set the scenario. And now we'll start talking about cross-site scripting, and then we'll kind of bring in these characters kind of going forward. Okay, so cross-site scripting, as a refresher, really the key idea is that Mallory injects evil JavaScript into the victim site, all right? Now, Bob, which is this is the Famazon site, okay, and you'll see that in a second. Anyhow, Bob visits the victim site, and evil JavaScript is then loaded into his browser. Now, after Mallory obtains cross-site scripting on the victim's browser, what could she do? It's just something to kind of think about. And really, there's many things that she can do. She can deface the website, do all kinds of stuff, but a couple of the ones that we're going to be kind of starting to look at, okay, so she can steal authentication cookies, right? And here's the key. She can make arbitrary requests to other sites on the internet or the local network. And this part, the second part, is actually what we're going to be hyper focusing on. Now, all right, now kind of blending in some of our security assumptions, right? So we're going to get into cross-site scripting, some of the mitigation advice that you commonly hear. And what is the common advice, really, on prohibiting cross-site scripting? Is it client-side validation? Or maybe do you commonly hear server-side validation? So for me, in my experience, I have always heard server-side validation. In other words, the server will drop the request if it has unexpected characters. So say we got Mallory, she's on trying to inject Famazon juice, right? Or just victim.example.com, just trying to inject it, and it's sending that payload to the API. The server will then drop that request in server-side validation. But here's the thing. People get on a little high horse, right? And they're like, client side validation is a bad practice, and they get, and it's understandable, right? Because there are people who just think, oh, well, we just do validation on the client. Mallory won't be able to send any, her malicious payload, which is not true because Mallory doesn't have to go through the browser to interact with the API, right? But we're told this as a beginner, client-side validation is bad practice, and it's an oversimplification. And here's the thing to really question. Is this always true? Okay, so taking that some of those items that we are told as a beginner and then reevaluating them. Is this always true or was this an oversimplification? All right, so let's start moving to some of those known unknowns. And here we go. DOM cross-site scripting, or in other words, a variation of cross-site scripting that doesn't involve the server at all. So here's an example, okay? So Mallory posts a link on a web form, okay? And it's got the victim on here, Famazon Juice, and whatnot. And the victim will click on the link because he trusts, he's seen this domain name before, whatever it is, okay? And he's like, oh, I trust that. So just kind of insert whatever kind of big name domain here, okay? Now, here's the thing is when the victim clicks on this link that has this inside of it, okay, right here, this is actually a DOM XSS payload if a couple of assumptions are met within the client-side JavaScript. We'll get into that in a second. But basically, this can get inserted into the DOM, and it looks a little cryptic. So maybe the victim or Bob won't really notice this. And this basically gets output into the DOM as this payload. And here's the key to DOM cross-site scripting, all right? And as client-side frameworks commonly store their state after that, they commonly store their state after the hash mark. And the reason why is because anything after the hash is not sent to the server. So let's just kind of go through some examples here. And so I'm going ahead and I'm placing the payload into basically into the browser. I'm just kind of simulating a person clicking on a link, and then boom, you see a hook.js basically get inserted into the DOM. So pretty crazy. Now, here's the assumption, right? Is basically maybe a dev thought, hey, client-side validation is pointless, all right? And so they're not really, and the result was really client-side code doesn't validate query string parameters before insertion into the DOM. So it can get pretty crazy. So, well, here's the thing. What is that hook.js? And that really allows the victim's browser to be controlled by Mallory's beef server. So we're just this kind of a natural pausing point. But then in the next half, we're really going to be getting into bringing this all together and showing the exploit that you can run in your local environment, which is going to be awesome.